So in this video, we are going to discuss about the transistor logic and the problem that will come from your semester exam, that the operation of two input TTL NAND gate means you have to prepare one NAND gate using a transistor, using the transistor. That is called the transistor logic. Basically, the transistors are used for making this gate is to make the fast response. So here I have already drawn this circuit because this circuit is quite critical. That's why I have already drawn this circuit. Here you see that Q1, Q2, Q3 and Q4, four transistors are there, and this Q1 is your two input transistor, and Q2, Q3, Q4 are your one input or one output transistors. So this is your VCC, that is the supply voltage. Now what is the truth table for NAND gate? The truth table for NAND gate is if A and B are the input and Y be the output, then for 0 0 the output is 1, for 0 1 the output is 1, for 1 0 the output is 1, and for 1 1 the output is 0. It means that when all the inputs are active high, then only we are getting 0, and in the rest three other cases the output is 1, that is the active high. So when the inputs are active high, the output is low, and when the inputs, any one of the input is high, then the output is high. So to make a NAND gate using the transistor logic, we should divide this circuit into three parts. One is AND circuit, because another second one is the inverter circuit, and third one is the totem pole configuration. So what does the totem pole configuration means? I will explain it later, but you see that the question is you have to prepare a NAND gate. NAND gate means not AND, it means AND gate is needed, because if we are giving the input in the AND gate, and if we invert it, that means that if we not add it, then it becomes NAND, not plus AND. So AND circuit and inverter circuits are simultaneously connected. And what is totem pole configuration? The totem pole configuration is nothing but when the two transistors are sit one upon another, that is called the totem pole. The Q4 is sit on the Q3. So when two transistors are sit one upon another, then they are called the totem pole configuration. And here one diode is connected between the totem pole configuration. In totem pole configuration, you should keep it on your mind that only one transistor among these two can work in one time. So let's start the circuit description. Now plus VCC is, you can say that 5 volt. It means high means, if this is high, it means 2.4 to 5 volt is your high, and if it is low, you are considering low, it becomes 0 to 2.3 volt. Okay, now so if we are giving the 5 volt, so one thing you have to keep on your mind that for this is the NPN transistor, not pointing, the arrow is coming out from the transistor, that is the not pointing. If the arrow is inside, then it becomes PNP. So not pointing transistor, all the transistors we use over here are the NPN transistor. And for NPN transistor, you should know that if any of the input is 0, then emitter base junction is forward bias and collector base junction is reverse bias. That means if we are giving that 0 and 0, that is the first input, 0 and 0. If it is 0 and 0, then what is happen? So current will come. So for 5 volt we are selecting the white marker. So if current is flowing through it, then I should flowing through it here, and as it is 0, so that means that this is the emitter base junction is forward biased, and this emitter collector, this is the base, this is the emitter, and this is the collector. So base collector junction is reverse bias. This is RB, this is FB. It means if it is reverse bias, that then no current should flow through it. As no current should flow through it, it means that this Q2 is connected to the reverse, the collector of this Q1. So but that means Q2 is connected with the Q1 by its collector. So as no current is flowing through it, so this Q2 is acts as a open circuit. It means if we are giving A and B both are 0, then what is Q2? That as the no current will flow through here, then Q2 becomes off. That means that it works in a cutoff region. Okay. Now what is about Q3? As you see that this is the emitter, this is the base, and this is the collector. So as no current is that, as this Q2 is the in the off, that means that it is in cutoff region. That means no current will flow through here. That means Q3 will not getting any current. So this Q3 is again become as a open switch. So it is also a off state. Now, what is about Q4? So I current will flow through it. Here, some portion of the current will flow through it, and it can flow through the base. This is emitter and the collector. As it is forward biased, so I current will flow from this diode, and if this is your output, then we are getting the output from here. That means Q4 is on state, D1 is on state, and Y is, we are getting 1 as plus VCC, that means high. Now if we are considering the case 2, that means for case 2, when so you take A as 0 and A as 0 and B as 1. So taking A as 0 and B as 1. So as the same thing will happen, because I have already told, if any of the input is 0, then the emitter base junction is forward bias and collector base junction is reverse bias. So the same case will happen. This is the forward bias, and this is the collector base is reverse bias. So again, no Q2 is no current will flow through the Q2. That means Q2 is a open switch. As it is a open switch, no current will flow through the emitter to the base. So it means this Q3 is also in open switch, so no current will flow through it. And again, for this, the current will flow in the same previous case, that some current will flow over R2, and it comes to the base of the Q4 transistor. And as it is a forward bias, the D1 is getting current, D1 is conducted, and as D1 is conducted, then you are getting the output as plus VCC. So for A0, B1, that means the Q2 is off condition again, Q3 is off condition again, Q4 is on condition, D1 is on condition, and we are getting plus VCC. Okay. Now consider the case number 3. So what is the case number 3 we are considering? We are considering anything that is the A becomes 0 and B become 1. Again we are considering A become 0, and B become 1. Or like that, A become 1 and B become 0. As again the same funda, that is the as any one of this input is 0, that means again that for Q1 the emitter base junction is forward biased and the base collector junction is reverse biased. Again Q2 is not getting any current, it is cutoff region, acting as a cutoff region or acting as an open switch. Again, as it is open switch, so Q3 is also open switch because Q3 is connected directly to the Q2. And for Q4, some current will flow through this Q4, and it is, as it is forward biased, so D1 is also forward biased, and we are getting some current. So for 1 and 0, again for the previous case, all are the same. That is the Q2 is off state, Q3 is off state, Q4 is on state, D1 is on state, and we are getting plus VCC. We are getting plus VCC. Now the fourth case. What is the fourth case? Now considering the fourth case, it is bit different because we are giving the A and B both are 1. That means if we are giving both are 1, then what happened? As so as so uh, changing the color. So as A and B both are 1, then what is the scenario? As A and B both are 1, then this is become nothing but the emitter base junction is reverse biased and this is forward biased. As it is forward biased, then what is the, as this one is forward biased, then what is the path of the current? So the path of the current is flowing like this. Okay, as path of the current is flowing like this, then what happened? So these become forward bias and these become reverse bias. So some current, you can say that some current, so this one is the forward bias for both A and B, and this one becomes the reverse bias. So for reverse bias, no current will flow through here. The current, the path which choose by the current is this. Now for this, what happened? Now these become forward biased, so some current will flow through here, and the this become the forward biased. So some current I will flow through Q2, Q3, and some current will flow through here. But as it is a for diode, so some current will flow in this direction. So Q4 is not getting any current. So as no current will flow through it, so the current which is conducted by the diode is in this direction, and we are getting output as 0. So what happened? It means that, so for uh, as A and B both are 1, so it means Q2 is what? Q2 is on because current will flow through it. Then what is about Q3? Q2 is on. This is the Q2. Q2 is on. What is about the Q3? Q3 is on. Now Q3 is on. So it is here it is the diode, and here it is the P and N junction diode. So the current is flowing over here from this Q3, as it is a PN junction diode, and current is entering to the negative. That means we are not getting any current from this diode circuit, and this become 0. So as Q4 is also in off state. That is, now no current will flow through it, and D1 is off because it is the diode is in reverse bias. The diode is in reverse bias. Again I am telling you that Q2 is on. Okay, Q4 is also Q2 is on, Q3 is also on, and the current will flow through it over here. As current will flow through it over here, but it is a N junction, it is P junction. So that means if current is entering through the N junction, this diode works as a reverse bias. In the reverse bias, that current cannot flow through the diode, and we are not getting any output, so the output becomes 0. Now if you consider VCC as 1 and 0 is 0, so we can consider VCC as 1. Again the output is VCC, it is 1, it is VCC, it is 1, and this is 0. So if A and B 0, output is 1, A and B 0 and 1, output is 1, A and B 1 0, output is 1, and A and B both are 1, the output is 0. This is nothing but the NAND gate configuration. So by this way we can make a NAND gate using 4 transistor and a diode, and you must know that is the totem pole configuration. one thing you should keep on your mind, that if that is the question comes, that is the draw the totem pole configuration, then just remove this AND part, AND circuit part, this inverter part, and this Q3 and Q4, which are the seat. The Q4 is seat above the Q3. That is called the totem pole configuration, and that totem pole configuration is connected with a inverter circuit, that is a NPN transistor. These two, that is green color and yellow color circuit diagram together, is nothing but the totem pole configuration. So thank you for watching this video. You will come in the next video with some multiplexer problem. Thank you very much.